Hello, this is bonding video number 1. At the end of today's video, you should be able to find the Lewis dot structure of a covalent molecule. In order to do this video, you need to have your video number 1 worksheet and your pencil. This was passed out in class, but if you don't have a copy, it is also on Edline. This is important because you're going to turn it in tomorrow, so don't forget it. Next, you might want to have your periodic table handy, but we will be showing that on the screen as well. Let us begin. We're going to find the Lewis dot structure of carbon tetrabromide. This is a covalent molecule because it has all nonmetals in it. In order to do so, we're going to follow a 4-step procedure. Let's start at the beginning. First, we need to find the number of valence electrons. To do this, you want to pull out your periodic table. Carbon, located right here, has 4 valence electrons. Plus, there's 4 bromines times by his valence electrons. Bromine is right here. He's going to have 7 valence electrons. So overall, you're going to have 32 valence electrons. Our next step is going to be to arrange the atoms in the correct order. To do this, the atom that has valence electrons as close to 4 as possible goes in the center. Carbon has exactly 4, so he will go in the center. After this, all the other atoms get arranged symmetrically. We have 4 bromines to arrange around the carbon. The lines that we're drawing are bonds. Each bond has 2 electrons in it. So right now we've done 1, 2, 3, 4 bonds, or 8 electrons. So we have 24 more electrons to go, minus 8. We're going to have 24 more to go. We're going to arrange these around the atom so that everybody gets an octet. Right now, carbon already has an octet. He has 1, 2, 3, 4 bonds. Each has 2 electrons. So carbon has 8 electrons around him. He's done. Let's arrange the other ones around the bromines. So we have 8 total done. We have 24 more to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. These dots represent electrons. And since they're not in a bond, they are unbonded electrons. Now we want to double check to make sure everybody has the octet rule. We already said carbon does. The bromines have 2 electrons in the bonds, 3, 4, 5, 6, 7, 8. This bromine has an octet. This bromine has 2, 3, 4, 5, 6, 7, 8. And if you keep counting, you will see that all the bromines have 8 electrons or an octet. We also want to double check to make sure we use exactly 32 valence electrons and no more and no less. So we're going to count the pairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pairs, or 32 valence electrons. This is a complete Lewis dot structure. Let's try another one. Water is something that you did a great deal of back in biology class. You already kind of remember what it looks like, but let's talk about why it has that shape based on Lewis dot structures. Each hydrogen has 1 valence electron. Each oxygen is going to have 6. Let's add those up. So 2 hydrogens times by the 1 valence electron plus 6 for the oxygen, we have 8 valence electrons. We now know how many total valence electrons we have. Step number 1 is done. Step number 2, find out who goes in the center. That's the one with as close to 4 valence electrons as possible. Oxygen has 6. Each hydrogen has 1. So oxygen goes in the center. The rest of them are going to get arranged symmetrically around it. There's 2 hydrogens, so we're going to arrange the 2 hydrogens symmetrically around the oxygen. When we're done doing this, we've used up 1, 2 bonds, or 4 electrons. Minus 4, we have 4 more to go. Now notice down here, hydrogen is an exception to the octet rule. He is going to end up with 1 bond or 2 electrons only. Which means that up here, this hydrogen and this hydrogen are done. So we have 4 more electrons to go. 1, 2, 3, 4 more to go. Oxygen now has an octet. It has 1, 2, 3, 4 pairs or 8 electrons. Each hydrogen has only 1 bond, 2 electrons, they're done. And I have 8 electrons total. 1, 2, 3, 4 pairs or 8 electrons. This is done. Another way you could draw it would be like this. Your main concern is you want all the lines to kind of go as a grid, like this, almost like north, south, east, and west, or like grid lines on graph paper. The other thing is you want the electrons to always be in pairs. They're either paired up in a bond or they're paired up by themselves. As we said earlier, these were unbonded electrons. They're also sometimes called unshared pairs. So unshared electron pair, because they are not in a bond. Okay, next one. Here we have 2 oxygens. Each oxygen has 6 electrons, so we have 12 valence electrons. The oxygen is going to be bonded with the oxygen. We've used up 2 electrons total, so we have 10 more valence electrons to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've used up our 12 valence electrons. Notice 1, 2, 3, 4, 5, 6 pairs or 12 electrons. This oxygen has an octet, but this one does not. This one has 1, 2, 3, 4, 5, 6 bonds, 6 electrons. It does not have an octet. So we're short electrons. And as in life, if you don't have enough of something, you have to share. So this electrons here are going to move over. So that when we're done, we have this. This right here is going to end up being a double bond. If it has 2 lines, it is a double bond. Each part of the bond has 2 electrons in it, so this has 4 electrons. So we have 4 electrons here, 5, 6, 7, 8, that's an octet. 4 electrons here, 5, 6, 7, 8, that's an octet. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total electrons. This is done. And it happens to have a double bond instead. Okay, notice that the electrons are still in pairs. This is important. Electrons are always in orbitals as a pair. So you do not want to do something where your electrons are spread out like this. Spreading them out is not good. Electrons are always in an orbital as a pair. Okay, last example problem. A good practice for you would be to stop the video and try HCN on your own. Then to come back and double check your work. We're going to go ahead and proceed now. There is 1 valence electron for hydrogen, 4 for carbon, and 5 for nitrogen, or 10 valence electrons total. The one in the middle is going to be the carbon because he has 4. And the N and the H are going to spread out around it. Notice at this point hydrogen is done. He makes 1 bond, that's the end of him for the octet rule. We've used 2, 4 electrons total. So we have 6 more to go. So 1, 2, 3, 4, 5, 6. Now at this point you notice that nitrogen here does not have an octet. There's not enough electrons to go around. So we're going to share these with the nitrogen. By doing so, the carbon here still has its octet. He has 1, 2, 3, 4 pairs, or 8 electrons. That's good. The nitrogen has 1, 2, 3 pairs, or 6 electrons. He still does not have an octet. So we're going to have to do additional sharing. These electrons will move up, and we will get this. At this point, we've used up our 10 valence electrons because we have, 1, 2, 3, 4, 5 pairs or 10 valence electrons. That's good. The carbon has 1, 2, 3, 4 pairs or 8 electrons. He has his octet. The nitrogen has 1, 2, 3, 4 pairs or an octet. That's good. This is our finished answer. And in this case, with 3, you have a triple bond, which is going to represent 6 electrons for us. There will never be something called a quadruple bond. These dots here, if you want to put them on the side or the top, that's fine. The main thing is not to spread them out. So an equally good answer would be something like this. That's just as good. Or this. Also just as good. What you don't want to do is spread them out because electrons are always in pairs. Okay, this is the end of our video. Make sure your video worksheet number 1 is completed and ready to turn in tomorrow when you come into the class. You're going to put it in the drop-off box as soon as you arrive.